Thank you very much. I'm really honored to be asked to come down here and speak to you guys today, so thanks so much. We're here to talk about really what defines a wetland and what a wetland definition is. Seems pretty simple, right? It's land that's wet. Now we can move on. But what I want to do really is put the microscope on wetland definitions today and really look at what is it about definitions that really can create challenges for us when we talk about being a researcher or being a wetland manager. Well, first I'll tell you a little bit about myself. I have been, actually I grew up in Massachusetts near Boston. So if you're wondering why I talk a little bit funny, that's why. But I've been in Alberta for 7 years, so it's not too bad. So before you start feeling bad for me because I'm from Massachusetts, I'll tell you, in a lot of ways, I was born at the right place in the right time for somebody who wanted to start a career as a wetland practitioner. Like Irene mentioned, I've been about 16 years I've been working as a wetland practitioner. And the reason I say I was at the right place at the right time is in the early 90s when I was in university and starting my career, wetlands were really heating up in terms of the focus on them from the regulators' points of view as well as the scientific point of view. And I think part of the reason things were getting so hot is because there was a lot of development pressure. The use of things like wetland definitions and wetland protocols were starting to raise some controversy and be the focus for a lot of different people and a lot of different disciplines. So because of that, I had a multitude of university courses. I was able to take my first job working as part of the National Wetland Inventory, and so it was a good thing for me. So what I'd like to do is I'm really going to focus on definitions of wetlands today. There's so many different aspects of wetlands we could talk about and study that will be not enough time for today, and certainly lots of room for those in separate presentations. But I do want to just briefly talk about wetlands classification and functions, just to put some of this into context. So the first step is to define a wetland. Is this location wetland or is it non-wetland? And once we've got that covered off and we've agreed it's a wetland, then we can talk about classifying the wetland and maybe evaluating the wetland. So we're really not going to talk about those things too much, but just a little bit here to touch on some of the reasons that these definitions actually become pretty important. So first of all, we define wetlands, and then we like to classify them and put them into different categories or into different buckets. And it's important to do that because, in order to make conservation plans and decisions about how we want to manage them, we kind of need to know what we have, what the different types are. And why we even care about wetlands, why wetlands are even protected in the first place, is because society has recognized just how important wetlands are, just how many functions and values and ecological services. There's lots of different names we can give these things, but when wetland regulations and wetland protection really became heated up in the, probably the 1970s, where it really got a lot of momentum, is that societies were realizing that the loss of these wetlands were actually hurting society in a variety of different ways. So just for example, when it became known to certain communities that their drinking water quality was poor, there was a need to spend lots of money to clean this water up and provide safe drinking water for the communities. And it was recognized that wetlands actually did provide those kinds of functions. So for example, wetlands on the landscape can trap water that flows over the land. It can remove sediment, toxicant nutrients, and ultimately help provide clean drinking water. In the absence of those in the landscape, then it costed more to provide drinking water, safe drinking water, and then there was quite a few additional risks to our community as to whether or not the drinking water quality was safe. And another good example of wetland functions is their role in natural disasters and floods, for example. So, places that were getting a lot of damage as a result of floodwaters recognized the fact that the wetlands that were in their floodplain areas may have disappeared or have been cut off, and as a result of that, flood damages were a lot more excessive. So these are some of the reasons why we focus on that. Again, those are subjects I'm not going to talk about a great deal today. Same thing with wetland classification. I do want to at least draw the distinction between what we do to actually define a wetland and what we do then to classify it. And just as an example for classification, you know, some of the examples of the primary classification systems we do see used are ones that like to break it up into things like water permanence. So some wetlands are permanently flooded. Some wetlands are seasonally flooded. Some wetlands are just temporarily flooded. Another example is classification system that like to break it up first to saltwater influence wetlands or freshwater influence wetlands. Perhaps we like to break it up even further into wetlands that are predominantly treed or have woody vegetation, or those that just have mostly flowers and grasses or herbaceous vegetation, or wetlands that are always open water. And so we could really break this down into really fine categories that way. The Canadian wetland classification system, for example, will break these wetlands up into peatlands first and then mineral soil wetlands, right? Peatlands meaning that they accumulate significant depth of organic matter. Why? Well, that's because wetlands are in some areas so wet for so long that the organic matter, the plant material that grows and dies, never has a chance to break down. Because in order for plant material to break down, well, it needs oxygen. And so as a result of that, you see a significant accumulation of peat. So there's your organic wetlands, and then your mineral soil wetlands are underlain by, you know, what's predominantly sand, silt, and clay materials. Maybe a little bit of peat accumulation, but not much. And then once we've broken our peatlands from our mineral soil wetlands, we can break them down further, as our peatlands may include bogs and fens. Our mineral soil wetlands may include swamps, marshes. So classification is important, but first we need to decide, is it a wetland or isn't it a wetland? And that's really what we're here to talk about today. So just for fun, let's go ahead and start by taking a little tour of some wetland definitions. Now, I want to tell you also that I am not biased about definitions whatsoever. I have never met a wetland definition that I do not like. But what we are going to look at a little bit today is the fact that some of them serve different purposes a little better than one another, but they're certainly all good. So I'll start with this wetland definition, and this is the definition that you'll primarily see in documents in Alberta related to policy and things like that. A wetland is land saturated with water long enough to promote the formation of water-altered soils and the growth of water-tolerant vegetation or plants and various kinds of biological activity that's adapted to a wet environment. So this is a good definition. I'm going to show you a few more definitions now, and you're going to see that there's really not a lot of variation between them. This one is almost identical. It's in the Canadian classification manual, and it's wetlands that are lands that's saturated with water long enough to promote aquatic processes that are indicated by poorly drained soils, by hydrophytic vegetation. By the way, hydrophytes is another word for a wetland plant. And various kinds of biological activity which are adapted to a wet environment. So not a lot of difference there. We used a couple of different words to describe things. This is a definition used by the U.S. Fish and Wildlife Service. Now, the U.S. Fish and Wildlife Service, their purpose of this definition was because they wanted to go about an inventory of wetlands. So this definition was mainly to serve the purpose of mapping and classifying wetlands to see just what is out there. Here we say lands are transitional between terrestrial and aquatic systems where the water table is usually at or near the surface, or the land's covered by water entirely. They must have one of the following attributes. At least periodically, the land supports mostly hydrophytes or wetland plants. The substrate is predominantly undrained hydric soil. Now, hydric soil is just a fancy word for wetland soil. And the substrate is non-soil and is saturated with water, or it's covered by shallow water at some time during the growing season of each year. So we're still seeing a lot of similarities. One more definition for you guys today. This is a regulatory definition. So this is the definition used by in the U.S. for purposes of the Clean Water Act, which regulates wetlands. Here they've come up with a new definition several years after the one we just looked at. And what they say is wetlands are those areas that are inundated or saturated by surface or groundwater at a frequency and a duration sufficient to support, and under normal circumstances do support, a prevalence of vegetation typically adapted for life in saturated soil conditions. So what we are seeing is something in common with every definition here. First of all, wetlands are distinguished by the presence of water, either at the surface of the ground or in the root zone. Wetlands have unique soil conditions that differ to the adjacent upland areas. And wetlands have vegetation that are adapted to wet conditions. So, and there's an absence of plants that cannot handle wet conditions, okay? So these are the three things that are in common. So, the reason we have so many definitions is because there are different purposes for some of these definitions. Now, a wetland scientist want a definition that they can use to inventory wetlands, that they could use to research wetlands, so that they can classify wetlands. Managers and regulators might need a different wetland purpose. First of all, by law, what is a wetland? Well, a wetland is whatever the law says it is. Okay, but when we have definitions that could be challenged by lawyers, that can become a concern. We may have wetlands that are lost because the consequence of the definition, certain areas didn't get included. So from that standpoint, we may need some legally binding definitions that aren't going to be challenged by lawyers. You know, a lawyer can exploit a weakness in a definition. So, you know, that's part of the evolution of the U.S. regulatory definition. In any case, the purpose of our definition, or the purpose how we plan to use it, really affects, you know, how we need to think about these definitions in the first place. So it seems like a pretty simple thing. There's water, there's unique soils, there's unique vegetation. But why is it a challenge? Well, first of all, how much water? We've said it needs to have water, but, you know, wetlands vary a great deal in the amount of water, or the duration of time in which they're flooded by water, the time of year that the water is present, or the difference in the amount of that water over years. You know, some years may be different than other years. And this is one area of quite a bit of debate. So how wet does it need to be? And can we say, as long as there's saturated soil for at least 2 weeks during the growing season, that's enough water, right? Now we're getting pretty specific. Does that make sense? Yeah, we could do that. We certainly could. You know, because part of the importance of when you actually start to apply this definition to different aspects of again, science and regulation, really want to make sure, above all things, that they're being used consistently. So another reason wetlands become hard to define is, you know, and it becomes difficult to take one definition and apply it to every single scenario is that they vary so much in size and in type, right? You could have anything from a small prairie pothole to a large expansive peatland. So it's hard to find a definition that's really going to kind of catch it all sometimes. There's also a great variation in location. You know, they have your coastal wetlands and your inland wetlands. There's a lot of variation between wetlands that are in the forest or in the prairie or in urban areas or in rural areas. Ones that are subject to quite a bit of human disturbance and those that are very natural. So trying to be able to define wetlands and kind of catch it all, and this is where the challenges really truly come from. So what I'd like to do now is take just a little tour on some of the wetlands so we all can finish this conversation with a little bit of a visual in our head. Okay, so this picture here is of a fen in the Fort McMurray area. So it's a peatland, an organic soil wetland taken from the air. Here's another example of a large fen. Here we're looking at a bog, another peatland, organic soil wetland that's actually treed. This is a picture of a swamp. I'm going to use all these slang terms now that we talked about when we talked about classification. This is a treed area, obviously, with skunk cabbage growing on the ground. The soils are saturated. This happens to be along a river. Now here's a picture of a wetland in southern Alberta. So you can see there's an area where the grass is quite a bit greener. And we could probably make a good bet at this point that the soils are different, where the grass is very green. The plant species that are growing there are quite a bit different. And there may even be some soil saturation or some standing water in that area. This is a shallow water wetland, right? And the duck is enjoying that. This is a picture of a lake, not very far from here, and then a fringe of a lake. This is also along the fringe of a lake. So now we start thinking, well, is that wetland? Where exactly do you draw the line? And that's one of the challenges that wetland practitioners face on a regular basis. You know, the wetlands are often called ecotones, or that transition zone between the aquatic environment and the terrestrial environment. And this is another reason why there can be a lot of debate about wetland definitions, is at what point does one start and the other stop? Can you say it's associated with the water body, or is it really associated with the upland? Here's another photograph in the grassland region of Alberta, and this photo is along a water course. So again, there's obviously some different plants growing, probably some different soil properties, probably some water present, maybe not over the soil, but in the soil up to a certain point as you climb up that slope. This is a picture of an alkali wetland in southern Alberta. Is that a wetland? Well, we did talk about the fact there needs to be water, there needs to be a certain kind of soil, and, well, there needs to be a certain kind of plants that can tolerate growing in there. This possibly, I mean, you could really kind of look at this both ways, couldn't you? Well, somebody dug a hole there. Well, was it wetland before they dug a hole? So these are the kind of questions where we start, you know, getting away from, you know, the science, and we start getting into, you know, some of the ways we want to look at this is it qualify as a wetland that should be protected under the law? And these are the kind of things that it can start becoming challenging. Now, this here is another example in the grassland region that is a very small area, and you might be able to tell from the photo that there's a different kind of vegetation. And again, very likely different soil characteristics, and maybe the presence of water at some point during the year. Well, this is a wetland that starts where they stopped dumping the fill material. So there is quite a bit of variety. Now, I'm not sure, that doesn't look like a wetland at all. In fact, it looks very much like somebody's backyard. Now, I'm not saying this is anything I can confirm, but there's a very good chance that somebody brought in some topsoil and used some seed, created a lawn, but at some time before that, it was maybe a very natural wetland, with trees even. I see a stump. And one thing we can tell for sure, that there is a line through that backyard at which the grass is really not that happy. Okay, so is it a wetland, or is it a former wetland? Well, if we walked away, would it turn back into a wetland? Well, really, what is a wetland then? We would have to think about our definition and if it really works in some of these scenarios. This is a picture of an area that has been farmed and tilled. Now, you can see some places where the farmer didn't till, and quite likely in those locations, we could say that those really do look like natural wetland systems. But there's also some places in that field that have been tilled, but are, again, kind of remind you of that backyard. The plants aren't too happy growing there. And there's obviously some different hydrology. The presence of water is probably in the soil, particularly, it's probably different in some of those areas. So are these wetlands? Or only where it's not disturbed? So anyways, that's just a tour of some kinds of wetlands that we are likely to encounter. Again, what's most important is that we have a definition that can be used for the purpose we need to use that definition. All the definitions that we looked at earlier today, some were used for legal purposes, some were used to be multi-user-friendly purposes, some of them were used for inventory purposes. They're all good definitions. But what is most important is the consistency in which that definition is used. We'd all like to think that we have a set of definitions that are going to be used the same way in the various circumstances. Now, applying a comprehensive definition in a uniform and a fair way, it requires trained people, right? And we need to ensure that our managers are armed with the fundamental understanding of the processes. Now, what we need more than anything to ensure that these definitions are applied consistently is probably an entire generation of people that understand the benefits, the purposes, the functions, the values, the different biological processes. And indeed, I think we are very much on our way. So one of the things that we do talk about at the course in our university Faculty of Extension program is where to draw the line. I'm not going to talk much about the policy side of things today, but I do want to touch a little bit on some of the things that wetland practitioners do when they are trying to determine whether or not they have the presence or absence of a wetland at a site. Now, wetland delineation is one of the things that has come out of some of the debates surrounding wetland identification and deciding whether or not you have a wetland on your site or not is the rise to different manuals and procedures and protocols. And those wetland delineation manuals, they outline a process for scientists to go out and consistently identify these key things that we talked about. Is there enough water? Is there the right type of soils, and is there the right type of vegetation out there? So according to many scientists, a wetland needs to have these three parameters met before it can be considered a wetland. Now, there's all kinds of exceptions and different scenarios whereby you may have such obvious hydrology or water presence that we don't really need to investigate the soils and the vegetation, or the vegetation may be so strongly wetland vegetation that we can pay a little bit less attention to some of the others. But there certainly are a lot of areas, especially as we travel up that gradient of the slope, where we need to be able to consider all those things. So the manual provides some of those principles that can be applied in situations like that. So one of the criteria, again, is there a presence of hydrophytes or wetland plants or plants adapted to a wet environment? Is there a presence of hydric soils or soils that are characteristic of being very wet? And is there the presence of hydrology? Is it wet enough to be considered a wetland? And generally speaking, these parameters are assessed along a boundary line or along a transect, and at some point you make the call, this is the spot. So a little bit more on that. One of the things we do is we look at vegetation sampling. We assess what plants occur in a specific data plot. We may look at the herbaceous or the low-growing grasses and forbs in a small area. We may look at the trees in the entire forest community, and so on and so forth. Then we've decided what plants are wetland plants and which ones are not. In order to do that, there is a national list of plant species that occur in wetlands. This is developed in the U.S. but used by practitioners all over Canada. And the list essentially has every plant species just about that you could think of, and it's given it a designation to see whether or not it qualifies as a hydrophyte. So part of that is your obligate plant species. Now, those, they say, occur in wetlands 99% of the time. And then we have our facultative wetland species that occur in wetlands somewhere about 67 to 99% of the time. The remaining part of the time, those plants can be found in non-wetland areas. And then we have our facultative wetland species, and those are 34 to 66% of the time you can find them in wetlands. So basically what we're saying is you're just about as likely to find it in a wetland as you are to find it somewhere outside of a wetland. And then our fac-up plants are 1 to 33% of the time in wetlands, so usually they're not. And then our upland plants, which are likely to be in wetlands less than 1% of the time. So the development of this list helped people go out and actually measure within their plant community how many of my plants are really hydrophytic. And in the U.S. protocol, the wetland delineation guide used down there, their rule is if you can figure out all your dominant plant species, not just you have one there, but there's many scientific methods to determine the dominance of each plant community. Once you figure out your dominant plants, more than half of those must be either facultative or wetter. Now this could be controversial as well. Now let's think about some plants. What if you have a community, I think Kentucky bluegrass can even fall into this category, that could be considered fac in some regions of the U.S. because, by the way, this list is regionalized. In certain parts of the country they have different lists. So if you have a plant species that is really the only dominant or a significant dominant that's facultative, is that good enough to say I have a wetland? No, it's not, and that's why we look at the other criteria. Now, if you have a plant community that's got nothing but skunk cabbage, which is an obligate plant and is always in wetlands, that may be a pretty good indication to meet that criteria. But we also got to look at the soils. And one of the things that's unique about wetland soils, and there's very many categories that we can't go into a lot of depth on here, but soil color is a primary thing we look at. Now, one of the things about soil is the most abundant mineral in soil is iron. And when iron is oxidized, it's very bright and orange in color. And when iron is reduced, because there's no oxygen available, and it becomes in its reduced form, it becomes very soluble in water. And as a result of that, the movement of water, maybe it's a fluctuating groundwater table or something like that, will actually take that iron and wash it away. So, the color of the soils can sometimes be a key indicator. This is an example of a hydric soil or a wetland soil that very much has had its iron depleted. You can see a couple places on the soil profile, particularly to the left, where there's an iron concentration, where there's a chunk of orange. Now, had that soil not ever been flooded or saturated or been in an anoxic condition, the entire soil profile very likely would have been that orange color. But because of its reduction and its movement as it went into solution as a reduced iron, it's deposited in certain places. So sometimes we talk about those as models or redoxymorphic features. So certainly looking at the soil can be very telling. Again, there's lots of scenarios where some of this can be unreliable, which is why we need to look at other things, like plants and hydrology. If you have a drained wetland, for example, you may see these colors persist for a very, very long time, long after the hydrology is gone and after the plant community is starting to shift. So it's important we are able to look at all those things. If a wetland is drained and we don't have a presence of water like we used to, does it meet the definition of a wetland anymore? No, I guess you could say it doesn't. One of the ways we look at soil color is the use of a Munsell soil color chart. And the soil scientists have developed definitions, again, of hydric soils. And they've developed a set of criteria as to what needs to be happening in your soil profile to meet the definition or to meet some of the criteria that were established. And then, of course, we have wetland hydrology indicators. So how long does it need to be wet? 2 weeks? Does it need to be flooded? And these are the kind of things that are defined quite a bit in some of the protocols. and some of the practices that are being used throughout the world, and some of the examples of hydrology indicators. Because one of the things, if you think about it, that's quite difficult about this is, as wetland scientists, we need a definition, and we need a method that we can use that we could use in a really rapid assessment. Because although I wish we could, we don't get to study these for years. If someone needs to know if there's a wetland out there, we've got one site visit. Now we can use historic photos, and we do, but we don't often have the benefit of studying this area. Is it wet? Is it wet most years? All these kinds of things. So we do have a number of indicators we can use. Certainly primary indicators like the presence of water is ones we like to see, but often, and particularly in floodplain wetlands, they're not wet very often. Their flooding is intermittent and infrequent. So we can look at things like debris that might have been caught during a flood period, or even silt lines on the trees, things like water-stained leaves, and so on and so forth. So there's quite a few indicators that have been provided for plants, for the soils, and for the hydrology. So these are some of the things that we do. These are some of the things that have been sort of offshoots from the actual definitions of wetlands. Like I say, I think the most important thing to us is that we have a way to apply definitions consistently, that we have trained people that are able to do that. And I think that's exactly where we're going. I think that we've been on that trajectory for a very long time. And, you know, that's why definitions can be just a little more complicated than they seem.